12.4 lesson is inverse matrices and systems. So for this one, they want to know this 2 by 2 matrix times matrix X equals this value right here. Now it'd be really nice if we could just go ahead there, multiply and go ahead and divide here, and then divide the corresponding spots. But if you remember from 12.2 lesson that for multiplication and division, you're not just multiplying and dividing corresponding elements. So there's another way that we're going to have to do this. So if we look at this equation up here, A times X equals our B. So this is our matrix A times our X matrix equals B. So how we solve for that, to get our X by itself, we're going to take the inverse of matrix A and multiply it by B. Okay, so we can go ahead and type this into our calculator, the two matrices. So I'm going to type in this first matrix as matrix A, the second matrix as matrix B. Oops. It's a 2 by 2. And then I'm going to go to matrix B. I'm going to type it in. Okay, and then from there, I want to go ahead and get out of the screen. And I'm going to go to second matrix. I'm going to have A highlighted. Click enter. And then notice we want to take the inverse of matrix A always. So then the inverse button is that fourth button down. Then we click on it, so then that says the inverse of matrix A. Then we want to multiply it by matrix B. And then that is going to be our answer. Okay, so I had to get in the habit of always just labeling above. Again, this is our A times our matrix X equals our B. And then it's always the inverse of matrix A times B. Now how this also applies is, if you think back to solving linear systems, we can use inverses to solve for them. So we'd set it up very similar. So these problems, we just want to do the setup. So we're going to have our X column, our Y column, and we're just writing the coefficients, and then our X column, our Y column, times our variables. So notice our first column was X's, our second column was Y's, so then our first needs to be X and then our Y, and then equals our answer column, so 9, -8. Okay, so then that is how we're going to set up our matrices. And for these three problems, we just need to set them up. We don't need to go ahead and solve for them. Now once we get down here, we want to actually start solving for our X and Y. So let's set it up just like up here. So we have our X column, we're just writing our coefficients, our numbers out in front, times our XY equals our 16 and then 12. So think of this as using this equation. Up here we can use our inverses. So A times our matrix X equals our B. So we're going to label this as our matrix A and this is our matrix B. And then we're going to solve for it, we're going to take the inverse of matrix A times B. So let's type in these two matrices. Okay, once we have them type it in, go to graph clear. Then we're going to go to matrix A. Then we wanted to find the inverse of that, so click that X to the -1 button. That means the inverse of matrix A times our matrix B. And we get 6, 2. Now what that answer means is our first variable, or our number on top, is our X, and then our Y. So then our answer we can just write as a coordinate 6, 2. Okay. And again, if we plug these back in, 3 times 6 is 18, minus our 2 is 16. It works. That would be our correct answer. Now, another way that you can do this if you don't like the inverses, even though they're introducing inverses in this section, if you want to go through and solve them using matrices, how I showed you back in the linear system section, you can go ahead and do that. Okay, so let me refresh just how to do that. So if we set this one up, again, we want to do our x column, our y column, and then our answer column. So we need to add this 4x over, and then plus our y equals 32. And then we have negative 2x, add that 3y over, equals negative 2. So once we get our x column, our y column, and then our answer column, instead of setting it up like over here, using our inverses, another way that you can do this, just make our one matrix, writing all the coefficients. So 4, 1, 32, negative 2, 3, negative 2. Okay, and then you're going to type in this matrix into your calculator. So it's a 2 by 3. And then go to second matrix, and then you're going to where it says RREF, click enter, and then second matrix, have matrix A highlighted, and then make sure you remember the ones diagonal means there is a solution, and then the last column is what your x and y is. So our x is 7, our y is 4. Okay. Either method, I don't care which way you use, you get that x and y solved for. So even though solving for the inverse is new for this chapter, if you remember back from linear systems how to use the matrices, then you can just keep using that method. Alrighty, let's do one more. If we take a look at the back side, it has an x, y, and a z. Okay, so we can do it either method. So if we take a look at just writing our equations, we have 3x plus 5y plus 0z equals 19. The z doesn't exist, so we're just going to put it as 0 as a placeholder there. We have x plus 3y minus 4z equals 1. And then 6x, notice there's no y, so plus 0y plus 8z, goodness, equals 12. So we have our x column, our y column, our z column, and then our answer column. So let's still look at it both methods. So if we use our inverses, the first method, we have just our coefficients. And then our variables, so x, y, and z, the order in which we had them, and then equals our answer column. Okay, this is going to be matrix A, this is going to be matrix B. So then we're going to take, to get this answer, we're going to take the inverse of matrix A times our matrix B. And that's going to give us what our x, y, and z are. Okay, so let's go ahead and type these matrices into our calculator. So matrix A is a 3 by 3. And then we're going to type in matrix B, which is a 3 by 1. Then we're going to have A. We're going to take the inverse of it times our matrix B. Oops. And then that's going to give us our x, y, and z. We can just write our answer as a coordinate. Okay, now the other way that we can do this, we can set it up just as one matrix with all of the coefficients, so 3, 5, 0, 19. Again, the answer column has to be last. Okay, so then we're going to type in this 3 by 4 matrix. And then we're going to go to the middle column down to RREF. And have matrix A highlighted. And then the ones are diagonal, meaning there is a solution, and then this is what the solution is, -2, 5, and 3.